Yeah, so
Thank you.
it's slightly different from me. I'm coming from a semiconductor manufacturer company, so clearly my background isn't directly in healthcare, but what we have is an interesting suite of applications specifically for AI at the edge. So, pretty good overlap with what you're talking about today. So, just a couple of scene setting slides. So, regardless of whether it's healthcare or not, but within the world of AI, there's a really broad range of different ways that you can implement AI, and there are sort of some high level characteristics that sort of dictate what your target architecture will be. So, one is maybe what's your power budget. If you're doing handheld devices, then generally you'd be battery powered, and you don't want to be consuming anything that looks like watts of stuff. So, maybe you want to do extended battery life, or at the very least you want something to be running for maybe an hour or two, quite realistically, if it's a medical device. Accuracy in healthcare generally is pretty high, but that's not always the case. You could have some relatively low accuracy, and you can also solve accuracy problems by accumulating images and running sort of AI processing on consecutive images to build up a confidence level. Similarly for latency. Now, latency, you would think you want it to be as quickly as possible, but that takes processing power. And so generally speaking, if you're capturing an image and running it, and you're happy to wait, for medical stuff, quite often you're happy to wait a few seconds, and that really the frame rate is very low there. You're just capturing an image and processing it offline. So, you can save a lot of power and a lot of processing power that way. And the final one down at the bottom there is to do with how much of the field of view is in, are you considering. So, and healthcare has a lot of different variables in play here. So if you're up close with, for example, the camera, and your face or your leg or whatever it is you want to take a picture of is dominating the picture, then actually you really don't need a very high resolution image, and you can get away with relatively low processing power on that, and the handheld device is quite realistic. If you're doing something more like scene monitoring, and you want to detect the mentioned earlier about falls in the elderly, or people moving around areas of buildings that you don't want them to, then this requires, obviously your objects are much smaller in the field of view. So you're, by definition, you're monitoring a much smaller area, and so you need a higher resolution to be able to have enough detail in that area. So all of these things tend to be considerations, and the higher towards the right is sort of higher amounts of processing power, which dictates a little bit the end form of the device. So to give you an example of some of the some of what we would consider to be true sort of edge applications, and some of these have healthcare implications directly, and some not quite so obvious, but would overlap pretty well anyway. So gesture detection is something that, although not obviously healthcare, but we are seeing increasingly that the desire to do hands-free operation. So in consumer goods, this is pretty straightforward because the consumer is pretty tolerant of things not quite working as needed. But actually, increasingly for things like automotive is quite similar to healthcare, that you really need a high level of precision. So the idea of being able to do gesture detection very accurately, but also on pretty low power. The good thing about gestures is generally you're pretty close up to the capturing device. So yeah, we've got some examples shown here. Gesture is actually a pretty good one for AI because your hand, with an IR sensor, your hand is generally pretty close to the thing that you want to do the gesture on. So we found actually we can do this in a very low power device. Battery powered gesture monitoring is really quite realistic. So presence detection, this would be something similar to, detecting if maybe the elderly are moving around parts of the building you don't want them to, in a healthcare setting, or, similar in hospitals, that sort of thing. So here, generally, this version is more about detecting when someone is up in front of an object. So this might be if you've got, a particular machine, a battery powered unit, you'd rather power it down when no one is around. This is a good example here, and you can do this in a very low power way because you've got, generally speaking, when the person comes up to use the equipment, they're in pretty close proximity to it. This one is probably more relevant though. This is very directly applicable to your elderly falling, and looking for a particular body shape in a scene that's not moving. You'd want to do scene analysis, and you'd want to be able to monitor that. So we have, I should say, for all of these are all based on reference designs that we supply. So actually, a lot of the legwork is taken out of this. Just as a side point, we find generally, particularly in Europe, actually, the barrier to entry on AI is knowledge of the engineers working on it. Quite often there are a lot of good ideas, but actually getting over the line of actually implementing it and understanding how to do AI and how to produce an AI application is the biggest barrier. And so we try to make that as easy as possible with some of the reference designs that we supply. I got a couple of slides on that later, but they're all provided free of charge on our website. So interesting background if any of you are in the development side. And then similar object identification. So now it wouldn't necessarily need to be humans, but you could be looking for, and this is actually one of the areas where I mentioned previously was looking at data captured, and you wanting to detect certain features on an ultrasound or something like this. Actually, you've got, generally speaking, quite a lot of time to do that. So you and your device needn't necessarily have a lot of processing power, because you've usually got maybe a half a second or a second or something. Depends what the user would tolerate, but it might even be longer, several seconds. So being able to identify particular features in an image, and then it all comes down to the original training data set. So the examples shown here, obviously not applicable all to healthcare, but the example is the same. You capture enough examples of the thing that you want to look at, and then the object identification algorithm will provide a good, in some cases very good first pass at that, and give you a very high confidence level whether the thing is or is not in view. I don't want to talk through this because this is not the right audience, but just wanted to show this just to give you an idea from our side that when if you wanted to start looking at developing a product, and we have some some companies that specialize in this area who are already quite well involved with us. We have a pretty complete suite of tools. So that include the software side, the hardware side, the reference design side, IP, and so on. So I would encourage you to make contact with someone from Lattice. You can just use sales@latticesemi.com or something like that. If you wanted to just get in contact, maybe you have a local contact. Depends what your organization looks like, but we have a pretty good set of tools that would help you get going as quickly as possible on that. Just a couple of things. This is not a sales pitch, but just a couple of things that are relevant here for things like healthcare. So one things, and we're down in the detail, but one of the things that we do, is relevant for electronics devices is the idea of high energy particles that cause state changes in the device. So things, as electronics get smaller and smaller, we find this becomes much more relevant, because the amount of energy that's needed to change the state of a chip gets smaller and smaller. And some markets don't care about this at all. Consumer, to some degree, some industrial applications are quite tolerant of it, particularly any video type applications don't really care. But things like things like healthcare for certain, aerospace, anything with high reliability requirements where you really, really don't want a random error to occur, really start to pay quite a lot of attention to this. And this is an area where we've recently invested in a new process technology that has a very good immunity to this sort of error. So our devices are being adopted pretty heavily by the high reliability customers. It's related to the process node that we use. It's in the detail. I don't want to get into that too much here, but just to give you an idea that architecturally our devices are pretty well suited to, very well suited to high reliability applications such as medical. Similarly, I'll skip over this in detail, but we've done some architectural requirements which allow you to reduce the power. Generally speaking, you don't want to have as few external devices as possible. So we integrate as much into our devices, specifically designing them for AI. So you can expect when using particularly our low-end devices that for edge AI, they're a very good fit for that sort of application, which is also shown by the applications that we have. So just an example on if you get these slides later, you can see them. It's quite a salesy slide. It's not the right audience for it here, but just to show that we, compared to something like an MCU, that's another pretty popular way of trying to do AI, or even something like an off-the-shelf dedicated AI processor. You can expect to get very good performance out of a low-end FPGA if it's been designed for AI. So just to finish, on our website, we have these reference designs that provide an excellent starting point for you. I would encourage anyone that's interested in just background detail on this for you to go and have a look at our website. There's a lot of good stuff anyway. You don't have to pay for it. You can go and have a look and download. There's with each reference design, there is a complete walkthrough guide. We provide the training material and the Python scripts and all of the all of the various layers of things you would need to be able to actually build a true AI application. And then tailoring it for the healthcare application or for your particular application is a case generally for AI. It's a case of training, training data set, which is kind of unavoidable anyway for most AI applications. But yeah, that's we provide a very good starting point on that. And that's largely I think my final slide, other than to say I work for an FPGA company, so I'm going to be quite pro FPGAs, but they're a very good fit for AI applications. So I think if you work with a design partner or have a design department in your company, then they should consider FPGAs as a very good fit for edge AI in particular.